So remember, we're splitting this chapter up into 2 pieces, and we're having a 50-point quest over each piece. So this first piece, we're going to practice one more time. So this is the pre-quest number 3 that I just handed out. So everybody's paying attention. Luke, turn around, face the front. Geechee, Ethan, stop, whatever it is you're doing. And we're going to do the sheet that I just handed out. I just handed it out. Geechee, did I give you a couple? You were supposed to give him one? All right, so here we go. Number 1. We are given 2 points, and we have to find the coordinates of MN. All right, so this is the vector that goes from M to N. Okay? Describe that motion. How do we get from M to N? What's going on there? -3, 1. Everybody okay with that? Getting from M to N? These are the coordinates of the vector. All right, if you have a question, you need Phil, where have you been?
I was late. I went out to my car to grab my what?
Did you go to Alpha period?
Yeah.
Okay. So then you went out to your car.
Yeah, to grab my advisor.
Okay, so now you're waiting it. All right, so now we're ready for number 2. Number 2 has a whole bunch of questions, but they all involve these vectors, these 2 vectors. All right, so A says V dot U. Who remembers how to do the dot product? V dot U.
X times X.
X times X, very good, Marissa. X times X, so 1 times 5 plus Y times Y. So that would be 5 plus 4, so the dot product is 9. How do we do a dot product? X times X, Y times Y, add them up, just like Marissa said. Okay? Now B says 2V minus U. So we're going to take 2 V's and subtract U. All right, what would 2 V's be? 2 negative 4. And then we're going to subtract U, which is 5 negative 2. When we subtract, we do it just like we do with matrices. We take first number minus first number. So that would be first number minus first number, negative 3. And then second number minus second number, which would be, watch your signs, negative 4 minus negative 2. Negative 2? Negative 4 plus 2. Got it? All right, what does C mean? What does this notation mean? The magnitude. And magnitude, remember, means Pythagorean theorem, right? So V is the vector over 1 down 2. So how long would it be? What's its magnitude? What's its length? Pythagorean theorem says root 5. Next, we're just adding V plus U. We're adding V plus U. So what would that be? If you just add these together, you're going to add the first ones and get 6, and add the second ones and get
0.
No, you don't get 0 when you add them.
-4.
You get negative 4, don't you? Negative 2 plus negative 2. Just add them together. What, Luke? Oh, I thought you were making some kind, I thought you were squinting or something. All right, E. Now, there's a lot going on in E. Do the inside first. Figure out the inside first. So V minus 3U. All right, so V minus 3 of these. Now, what would 3 of these be? 3 U's. 15 negative 6. So we're taking V minus 3 of these. All right, so here we go. 1 minus 15, negative 2 minus negative 6. And then we need the magnitude of it. So first we figured out what all this stuff was on the inside, and it came out to be negative 14.4. Now we need the magnitude of that. Magnitude, remember, is Pythagorean theorem, right? So negative 14.4, 16 and 196. I got 212. Did I do that right? The square root of 212? Yeah. And I'm sure 212 breaks down. So it's 2 times 106, which is 2 times 53. 253 for the final answer, unless I made a mistake. Anybody have a question about that? Make a mistake? Like, did I do okay? All right, one more in this section. We have to do U minus V. Okay, now, be careful on the order there. It's U minus V. So make sure you're subtracting in the right order. So U minus V. All right, so here we go. 5 minus 1. Negative 2 minus negative 2. That one's 0. There you go. So that's the answer to F. Alrighty? Alright, next. Find the components and magnitude of AB. Well, this is easy. You've done both of these already on this paper. We have 2 points, and we need to know the coordinates or the components of the vector that starts at A and stops at B. So you're going from negative 2 to 5, that is 7. And you're going from 1 to 4, that is 3. So there are the components. That's all we mean by components. Find the coordinates of the vector. Now we want its magnitude. Well, we've already done a couple of those. Magnitude means Pythagorean theorem, right? Pythagorean theorem. So if I go over 7 and up 3, what's my magnitude going to be? Square root of 58, which does not break down. So it's just the square root of 58. Okay, so components, magnitude, those are easy. You know those things. No need to be confused. Now, number 4 is asking also for the components. But now we have a picture. Now, what do we mean by components? We mean X and Y, right? Now, when angles are involved, how do we find x and y every time? We use sines and cosines. And for x, we always use cosine. So x is going to be 18 cosine 126. X is going to be 18 cosine 126, and y is going to be 18 sine 126. Now, does that confuse anybody? Just occurred to me, I'm doing that a little bit different than I did it last time. Are we okay with that?
Why wouldn't you subtract 180 from 126?
If you want to do it that way, you absolutely can. And let's see, that angle would be, what, 54? So x would be 18 cosine 54, and y would be 18 sine 54. That is absolutely fine. The only thing is, if you do it this way, you have to remember to make x negative. You have to make x negative. If you do it this way, x will come out negative automatically. So it's completely up to you. If it makes more sense to you, and it does in terms of the trigonometry, to make this triangle, that is absolutely fine. But you have got to remember to put the negative on the x there. If you actually use the given angle, it'll come out negative on the film. So either way you do it, and again, you get to pick which way works best for you, but you better be getting these numbers. Okay, so this would be the answer to the question. No matter which way you did it, you should get the answer right there. Okay, so you can actually draw the triangle like this, or you can use the 126. Either way, this is the answer. Okay, did everybody get this answer, however you did it? Alright. Alright, number 5, question number 5 says, find the angle between V and U. Find the angle between V and U. We have a little formula for this. Anybody remember what it is? Well, no, it's not radius times radians. That would be arc length.
Magnitude times magnitude times.
Okay, it involves magnitude times cosine. And what does that equal? That's set equal to a number. What is the number that's over there? The dot product. The dot product. Now, kids, you know the quest you get is going to look just like this. You now have, this is the third copy you now have. You know it's going to look just like this. You know there's going to be a question. It will be number 5, and it will be at the top of the page. And it will say, find the angle between these two vectors. You need to know that. Write it down. Get it learned. It's going to be a test question. Now, our two vectors are negative 2, 5 and 3, 2. We need their dot product. Well, we already talked about that in an earlier question. How do we find the dot product? Take the x times x. So that would be the dot product. Let's see, that would be negative 6. Y times y. I got 4 for my dot product. Did you? X times x. Y times y. Add them up. Is that good? Now, magnitude. All right, I need the magnitude of this first vector. So you can draw a picture of it and do the Pythagorean theorem. Or you know it's going to be 2 squared and 5 squared, so it's going to be the square root of 29 times the magnitude of that second vector, which is over 3 up 2. So 9 and 4 through 13 times the cosine of the angle. And remember, that's what we're looking for. Find the angle. Theta is what we're looking for. Now, what do I do? When I worked these out before, what did I suggest maybe we do? Multiply the 29 and the 13, so we have the square root of 377. Now what? Divide. So 4 over the square root of 377 is cosine theta. And how do I find theta then? What buttons do I press on my calculator? Second cosine, special cosine, second cosine. So second cosine. And I got 78.11 degrees. But I'll let somebody confirm that. Make sure I typed it in right. We good with that?
So to get square root of 977, you just do square root times, or cosine times.
Just 29 times 13.
Just 29.
Yeah, just put those two together and get one square root instead of having two separate ones. So just multiply 29 times 13.
Alright.
It just makes it easier to type this part in on the calculator if I might have one number down there. Alright, how do we find the angle between two vectors? Dot product equals magnitude times cosine. Alright, number 6. Remove the parameter and write one equation. Alright, so let's just look at this for a second. Remove the parameter. Okay, what does that mean? Remove the parameter. Get rid of t. Alright? You got options, but the way we've been doing it, the easiest way I think, is to do what? Get t alone and substitute it in. So if I get t alone in this equation, t equals y minus 1. That's this equation. So I'm going to take this now and plug it into the other equation. So x equals 2 plus 3 times y minus 1. Paul? So I took my y minus 1 and plugged it right in here for t. So x equals 2 plus 3y minus 3. X equals 3y minus 1. Now, have I written one equation with no t? Yep, we're done. Now, if you want to rearrange that and do some other stuff to it, you can, but it's good right here. Number 7, kind of the backwards of this. Write parametric equations. That means these kind right here. So you're going to write x equals and y equals. And I clued you in. I wrote that down over here in the answer spot. And my points are negative 1, 2, and 3, negative 5. Okay? Now remember, the equations that you write are going to be something plus something t for y and x. In other words, they're going to look just like these from question number 6. Your answer to 7 is going to look like 6. Who remembers what goes here?
No, that's one of the points.
One of the points. So you can put -1, 2. Put that point, -1, 2, x and y. Or you can put that point, 3, -5. It's up to you. Pick one of the points in for x and y. Now, dollars to donuts. Somebody's going to put the other point in there. And I'm going to have to mark it off and make some kind of comment. The other point is not what goes in here. What goes in the T spots? The slope. You have to do a little work. You don't just plug in the 2 points. You have to find your slope. So 2 minus -5, -1 minus 3. I got 7 over -4. Double check that. Is that okay? Now here's the tricky part. Remember, slope is y over x. So where does the 7 go? In the y equation. The -4 goes in the x equation. Find the components of the velocity vector for an airplane flying at a speed of 362 on a course of 228. Okay. Now, you need to pay attention. This is a compass problem. Do you recognize that? This is a navigation problem. So your setup is different than normal. So a course of 228 is going to be over here, between 180 and 270 is my 228. And he's flying 362 miles an hour. So that's the picture. Everybody good? But I need the components. What are the components again? The components are just x and y. So I'm going to go ahead and draw my picture. And I have to find the x and the y that go with that picture. Now I need a piece of information before I can do that. What do I need to figure out? That angle right there. Now, keep your eyes open. That's the angle between 228 and 270. How big is the angle between 228 and 270?
42.
42. $228 to 270. So what will x equal? 362 cosine 42. Remember, it's always cosine angle. So the 42 goes with the cosine. And then 362 sine 42. So I'm going to type those in, and I'm going to get my x and my y. What do you think? Be careful. Which quadrant are we in?
They both have to be negative.
What do we know about x and y? When we're down here, when our vector is down here, look at this x and this y. What can you tell me about them? They're both negative. we have got to make sure that whatever picture we've drawn, the X and the Y match up to that picture in terms of positives and negatives. All right, next page. Find a unit vector in the same direction. All right, who remembers how to do this? A unit vector is a vector whose length is 1. How do we find a unit vector? Maddie, you feeling okay? How do we find a unit vector?
Hypotenuse, gotta be 1.
Okay, we need to make the radius 1, the hypotenuse 1. This hypotenuse is not 1. How do we make that happen?
Put it over, under.
We divide each of these by what? The magnitude. So we got to find the magnitude of our vector. That's Pythagorean theorem. So this would be what? The square root of 18, which is 3 root 2. So we're going to divide these by 3 root 2. This one does have a little bit of canceling. We'll want to cancel. So 1 over root 2 and negative 1 over root 2 are the coordinates of your unit vector. Now, if you want to rationalize that, multiply top and bottom, you can, but you don't have to. You can leave it like this. So, to make something a unit vector, you need its magnitude. Magnitude is the Pythagorean theorem. 9 plus 9, 18. That reduces to 3 root 2. Divide each coordinate by the magnitude, and in this case we could cancel. That doesn't always happen, but we did this time. Okay? How do we find a unit vector? We divide the coordinates by the magnitude. How do we find the magnitude? Pythagorean. Alright, now we've got this vector 9, negative 7, and we want its magnitude and its direction angle. So I'm on number 10, I have a vector 9, comma, negative 7. So if I draw a picture of it, it looks like this, over 9, down 7. Can I find its magnitude? I hope so. We've done about 1 million of these. Pythagorean theorem would say what? 81 plus 49, what is that, 130? So the magnitude would be the square root of 130, which is 2 times 65. Oh, I don't think that breaks down. So I think it's just the square root of 130. Now the direction angle is this. Right here. That's the direction angle. That's going to be the answer to the question. What do we need to find first? This little guy right here. I'll call him theta. Got to find him. And how will I go about finding that little angle right there? Second tangent. I know the tangent of that angle is 7/9. Remember, take or leave the negative. Take or leave it. It's not going to show up in your answer. So the tangent is 7/9, so I have to second tangent 7/9. To find that angle, that little angle, I'm going to second tangent 7/9, and I get 37.87. Now, that angle, though, 37.87, is not the direction angle. Remember, This is the direction angle. So how are we gonna find that number? Subtract it from 360, yep. And the direction angle is 322.13 degrees. Now, am I always gonna be subtracting from 360?
No.
No, it depends where your picture is drawn, right? Sometimes we subtract from 180, sometimes we add 180. It just depends where the picture is. All right, we're almost done. Number 11. Are these guys, okay, so here are the two vectors. And we want to know if they're parallel or orthogonal, which means perpendicular, or neither. How do we figure that out? What do we have to figure out? What their slope is, rise over run. So the slope here is 1 over -3. Now you guys, just think about it. This vector goes left 3 and up 1. So isn't its rise over run 1 over -3? And this rise over run is -2 over -6, which is 1/3. So one of your vectors has a slope of -1/3, and the other one has a slope of +1/3. Are they parallel to each other? No, because if they were parallel, they would have exactly the same slope, and they don't. Are they perpendicular or orthogonal to each other? No, because if they were orthogonal, they would have opposite reciprocal slopes. They got opposite, one's positive, one's negative, but they're not reciprocals. So therefore, if they're not parallel or perpendicular, they must be neither. Right? And one more. Are these two vectors equal to each other? Why or why not? Well, how do we decide? We find the components. We figure out what they are. So what are the components of AB? No. We're going from A to B. So how many steps are we taking to get from 1 to -4? -5. To get from -3 to 7? 10. So there are the components or the coordinates of AB. Now do the same thing for CD. What are the components of CD? Nope, -2 to 7, or -2 to 5 is 7, and -1 to 3 is 4. Are they equal? No, they're not equal. Why not? They don't have the same components. They move differently. If vectors are going to be equal to each other, they have to move in exactly the same way. These do not. Okay? All right, your homework is due tomorrow. That's 616263. So I'm giving you 8 minutes right now to work on that. 616263. So if you haven't started yet, get out some paper and get started. If you have started, great. If you're finished, God bless you, turn it in. We will have our quest not at our next class meeting, but the one after that. Those of you that are going on retreat,